Imagine this. A tech giant, like the Google of China, right? They spend years building these super advanced AI models, all secret, locked down, proprietary.
Yeah, the usual playbook for big tech, really.
Exactly. And then, just completely out of the blue, they release their absolute best one, their most powerful model, open source, free.
And it's actually beating some of the big Western names.
Right. Pretty shocking stuff.
Definitely raises eyebrows.
Well, that's exactly what Baidu just did with ERNIE 4.5. And this isn't just, another incremental update. It feels like a bombshell. It's fundamentally shaking things up in the global AI scene.
It really is.
We're talking about a system with, 424 billion parameters?
That's the number. Huge.
And it's outperforming competitors like DeepSeek on, I think, 22 out of 28 benchmarks?
Yeah, significant wins there.
So today, in this deep dive, we're going to unpack this. Baidu's really dramatic strategic U-turn, the tech brilliance behind ERNIE 4.5, and what this whole shift means for, well, everyone involved in AI.
And understanding this story is, I think, absolutely key if you want to get a handle on the big trends shaping AI right now.
How so?
Well, you've got the undeniable rise of Chinese AI, for one. Then there's the growing power of open source models really challenging the status quo. And all this puts increasing pressure on companies like OpenAI, Google, the ones with traditionally closed, often quite expensive systems. It's like this perfect storm of factors just shifting the entire landscape.
Okay, so let's start with the big surprise then. The complete reversal in strategy. Robin Lei, Baidu CEO, he was pretty clear just months ago, wasn't he?
Oh, yeah, very vocal.
Saying that closed source was the only way forward. I mean, for a company that poured years into building up proprietary advantages with their ERNIE models since, 2019.
Yeah.
This is a massive U-turn. What triggered it?
Well, a lot of people are calling it the DeepSeek moment.
DeepSeek, right, the startup.
Yeah, a relatively new Chinese startup. They came out with models that didn't just match, but in some cases actually beat leading Western AI models.
Wow.
And critically, they did it at a tiny fraction of the cost. That sent, well, shockwaves doesn't quite cover it, especially through Baidu.
I bet.
DeepSeek basically proved you could hit world-class AI performance without these giant, secret, proprietary systems. They really championed open development, lower costs, making it accessible.
So that sounds like a serious wake-up call for Baidu. I mean, DeepSeek kind of pulled the rug out from under their whole strategy.
Exactly. And Robin Lai's public statement was pretty amazing, actually. He flat out said, DeepSeek's success prompted our shift towards an open source approach.
No kidding. He actually credited them.
Yep. For you to really get the scale of this, just imagine Tim Cook suddenly saying iOS is going open source because, I don't know, Android got too good.
Okay, point taken. That's huge.
It's that level of strategic pivot. But it's probably deeper than just DeepSeek breathing down their neck. If you look at the bigger picture, Baidu was feeling pressure from lots of angles.
Like what?
Okay, so ERNIE bot, their existing chatbot, already had 300 million users. Massive base. Meanwhile, DeepSeek's models were getting picked up globally fast, which proved there's a real hunger for powerful AI you can actually access. And then, crucially, OpenAI started blocking API access for Chinese startups. That was July 2024, right?
Yeah, I remember that.
So suddenly there's this urgent need for strong homegrown alternatives in China. Add to that the general cost pressure businesses everywhere are facing, always looking for cheaper AI that still performs.
So a whole confluence of factors.
Exactly. The calculation for Baidu became, do we fight this open source wave and risk losing ground, or do we jump in and try to lead it?
And they chose to lead.
They good. And the timing here is fascinating. This move just ramps up the global AI race, makes cost a critical battleground now, and it plays right into those geopolitical tensions pushing for more independent AI ecosystems. It really makes you think, what pushes a company to effectively give away what looks like its crown jewels?
That is the million-dollar question, isn't it? And it leads us right into why they could make such a bold move, because this pivot wouldn't mean much if ERNIE 4.5 wasn't, genuinely groundbreaking itself.
Absolutely. The tech has to back up the strategy.
So let's dig into that. What makes this model so impressive under the hood? It's not just one model, is it?
No, that's right. It's actually family. 10 different versions, scaling from a tiny 0.3 billion parameter model up to the monster 424 billion parameter one.
Okay, and that big one, the flagship. ERNIE 4.5, 300B, A47B. Quite a name.
Rolls right off the tongue, does that? But yeah, 424 billion total parameters, but using a mixture of experts or MOE approach, so it only activates 47 billion parameters at any given time.
Ah, okay, so it's efficient.
Very efficient.
Mm.
And they hit this impressive 47% model FOLP's utilization during training. MFU, basically how much of the theoretical compute power they actually used.
And 47% is good.
Yeah, it's really good.
Yeah.
Most large model training runs are maybe 30–40% efficient. So 47% means they're squeezing way more performance out of their hardware. Serious optimization.
Okay, impressive efficiency. But what's the real innovation here?
I think the standout is what Baidu calls a heterogeneous modality structure in their MOE architecture.
Okay, translate that for us.
Right. So most models that try to handle multiple things like text and images struggle with what's called modality interference. Training on images might mess up the text abilities, or vice versa.
Okay, I can see that.
Baidu's approach uses a clever mix. Some parameters, some experts in the MOE system are shared across different data types, text, images, audio, video. This builds general understanding.
Right.
But then they also have dedicated parameters, specialized experts just for text, just for images, and so on. So it gets broad intelligence and deep expertise in each area without them stepping on each other's toes. It's a neat solution to a really tricky problem in multimodal AI.
So it can genuinely handle text, images, audio, video all together natively without performance hits? That sounds like true integration.
Exactly. It's not like separate systems bolted together. It processes all these different content types within one unified architecture. And you see this in what it can actually do.
Like
Understanding memes, visual humor that needs context, processing video with a real sense of what happens over time, doing cross-modal reasoning, like asking it text questions about a picture it's looking at. And it has strong cultural understanding across different media.
Okay, that's impressive. And the benchmarks back this up.
They definitely do. It beat DeepSeek v3 on 22 out of 28 benchmarks, as you said. Performance is reportedly competitive with GPT 4.5.
Whoa.
But here's the kicker, at about 1% of the cost.
1%.
Yeah. And it shows better reasoning and multimodal skills than models like Qwen 2.5. Think about that cost figure.
Right.
Roughly RMB 0.004 per 1,000 input tokens. That's dramatically cheaper than many Western APIs for comparable power.
That cost point alone is a potential game changer for businesses, surely.
Absolutely.
Were there other specific tech tricks that enabled this level of performance and efficiency?
Oh yeah, they threw a lot at it. During training, they used something called flash mask dynamic attention masking. Basically, it helps the model focus attention more efficiently on the important parts of the input, smarter processing.
Okay.
For video and audio, they developed spatiotemporal representation compression, clever ways to shrink down the data from long sequences without losing the crucial timing information.
Makes sense for efficiency.
And to boost its smarts, its reasoning, they used knowledge-centric training data construction, meaning they specifically built data sets designed to teach it better reasoning and factual knowledge.
So targeted training.
Right. And then after the main training, they didn't just stop there. They used standard techniques like supervised fine-tuning, SFT, and direct preference optimization, DPO. But they also introduced their own novel method called unified preference optimization, or UPO. It sort of combines reinforcement learning with preference tuning to really refine the model's behavior and alignment.
Interesting. What about running the model, the inference side? Is it still demanding despite the MOE?
That's another area where they've innovated. They use techniques like convolutional code quantization, fancy term, but it lets them run the model using 4-bit or even 2-bit precision for its weights.
Which means?
Which means significantly less memory and compute needed to run it, often without a major drop in performance. So you could potentially run this massive 424 billion parameter model on hardware that's much more accessible, much more modest than you'd normally expect.
Making it usable for smaller companies, maybe even individuals?
Exactly. Accessibility seems key here. And you have to remember, none of this happened overnight. It builds on years of work. Baidu put in their own deep learning framework, Paddle. That deep investment is really paying off now.
Okay, so incredible tech, incredible efficiency, and now it's open source. Let's zoom out again. What does this mean for the global AI chessboard, starting maybe with China itself and this idea of AI sovereignty?
Right. Well, first and foremost, it gives China a truly powerful, homegrown alternative to Western AI.
Which is crucial for them right now.
Absolutely. Think about the context. OpenAI blocking API access from China starting July 2024. ongoing U.S. restrictions on exporting advanced chips to China, there's immense pressure and focus on self-reliance.
Mm.
ERNIE 4.5 lands right in the middle of that. It's a top-tier alternative, it's not subject to those external restrictions, and, importantly, it likely has a deep understanding of Chinese language and culture baked in.
Addresses a lot of needs at once.
Precisely. But then, by making it open source, Baidu isn't just serving China. They're effectively offering these frontier AI capabilities to the entire world.
Without the usual strings attached.
Exactly. Without the Western API costs, without the rate limits, without the potential political complications or usage restrictions that can come with proprietary U.S. models. This creates some really interesting new dynamics.
Okay, break those down for us. What does it mean for different groups?
Well, for developers globally, it's fantastic news. You get free access to a genuinely state-of-the-art model. It's under an Apache 2.0 license, which means full commercial rights. No API bills racking up, no hitting usage caps, fewer geopolitical hurdles depending on where you are. It's incredibly empowering, especially for startups or researchers outside the main Western tech hubs.
Okay, that's developers. What about the big competitors, OpenAI, Google, Anthropic?
For them, it's serious pressure.
Hmm.
Now there's a credible, free alternative that performs comparably well on many, many tasks. So the question becomes much harder for them. How do you keep justifying premium subscription fees or high API costs when powerful capabilities are available openly?
Puts the squeeze on their business models.
It certainly does. And then for the broader open source movement itself, ERNIE 4.5 is another massive validation point. It joins models like Meta's Llama, Alibaba's Quinn, Mistral's models, all proving that open development can produce frontier AI. It strengthens the argument against keeping everything locked down.
You mentioned the China factor earlier. Some organizations, particularly in the West, might pause before using a Chinese-developed model, thinking about security or data privacy. Does open source help there?
It absolutely helps. That's one of the key advantages of open source in this context. Because the code is open, you can inspect it. You can audit the model's weights and architecture. You can deploy it entirely on your own infrastructure, keeping your data firewalled.
So transparency is the antidote.
To a large extent, yes.
Hmm.
It offers a level of scrutiny and control that's just impossible with a closed black box API. We're seeing the industry react already, right? Meta keeps investing heavily in Llama. Google released its Gemma models. There's growing demand, especially from enterprises, for AI they can actually look inside and trust.
It's definitely a trend.
It really forces you to ask that fundamental question. What's ultimately better for driving AI innovation and adoption forward? Is it wide open accessibility, or is it more controlled, perhaps more cautious development? ERNIE 4.5 adds a lot of weight to the accessibility argument.
Okay, let's maybe dive a bit deeper into some of those specific technical innovations you mentioned earlier.
All right.
The things that really make ERNIE 4.5 tick. You
Yeah.
talked about the heterogeneous MoE architecture.
Right, the way it handles multimodal data.
Can you elaborate a bit more on how that solves the challenge? You mentioned shared and specialized parameters.
Yeah, so think of it like having a team of specialists. You have some generalists, the shared parameters, who understand the basics across text, images, audio, video. They provide a common foundation.
Okay.
But then you also have dedicated experts, the specialized parameters, for each specific modality. One expert is really good at understanding linguistic nuances in text. Another is brilliant at recognizing objects and images. Another tracks changes over time in video.
Okay.
By having both, the model learns connections between modalities through the generalists, but maintains peak performance within each modality thanks to the specialists. It avoids that interference problem where training for one skill hurts another. It leads to that truly unified understanding. We talked about understanding memes, answering questions about images, that kind of thing.
And you mentioned some specific training innovations too, flash mask.
Right, flash mask, dynamic attention masking. It's about making the attention mechanism, how the model decides which parts of the input are most important, more efficient. Instead of looking equally hard at everything, it dynamically focuses resources on the relevant bits, saves compute.
And the spatiotemporal compression.
That's key for video and audio. Those sequences can be incredibly long. This technique finds clever ways to compress the information about how things change over time, spatiotemporal, without losing the essence. Makes processing long videos or audio files feasible.
And the knowledge-centric data.
That was about curating the training data itself. Rather than just throwing massive amounts of random web text at it, these specifically constructed data sets designed to improve the model's reasoning abilities and its grasp of factual knowledge. Quality over just quantity, in a sense.
Smart. And the post-training, you mentioned UPO, Unified Preference Optimization. How does that differ from standard methods?
So SFT Supervised fine-tuning teaches the model specific skills by example. DPO, direct preference optimization, learns from pairs of responses, one preferred over the other. UPO, as Baidu describes it, seems to combine reinforcement learning ideas learning through trial and error with rewards directly with that preference data. The goal is likely to get even more fine-grained control over the model's behavior, making it more helpful, honest, and harmless, potentially more effectively than DPO alone.
And the inference optimizations, the 4-bit and 2-bit stuff, making it run on less powerful hardware.
Yeah, the convolutional code quantization. It's a technique to shrink the model's size drastically by representing its parameters with fewer bits. Doing this well without hurting performance is tricky, but they seem to have cracked it. This democratization aspect, making powerful AI runnable without needing a supercomputer, is a huge part of the open source value proposition.
And this all ties back to their paddle framework.
Exactly. These aren't just generic optimizations. Many are likely deeply integrated with paddle, giving them an edge that might be harder to replicate directly on other platforms like PyTorch or TensorFlow. It highlights the value of building a full stack from the framework up to the model.
So this wasn't just a reactive move to DeepSeek. It's clearly the culmination of years of focused R&D.
Absolutely. It's a sustained, deep, technical investment bearing fruit combined with a bold strategic shift.
Okay, wrapping things up then. What are the big takeaways here? What does ERNIE 4.5 signal for the future?
Well, I think ERNIE 4.5 is more than just a model. It's a really clear signal that AI development is shifting. It's moving away from being dominated by just a handful of Western companies towards something much more distributed, much more globally accessible.
What kind of future scenarios could unfold from this?
We could see a few things. First, maybe an open source acceleration. If models like ERNIE 4.5 really take off, it could force the whole industry towards open source faster. Competitive advantage might shift away from just having a model to being really good at deploying it, customizing it, building applications on top.
Makes sense. What else?
Second, maybe a geopolitical AI split. You could see distinct AI ecosystems forming. Western models dominant in some markets, Chinese models like ERNIE becoming the standard in China, and perhaps other regions, maybe the global south, less cross-pollination due to political tensions or security concerns.
A sort of digital iron curtain for AI.
Potentially, or at least distinct spheres of influence. And third, possibly the commoditization of AI. If several powerful open source models become readily available and achieve similar performance, the core AI capability itself might become like a utility, a commodity. The real value then shifts higher up the stack to unique data, specific applications, distribution channels.
Interesting possibilities, but the immediate impact seems clear.
Yeah, immediate opportunities for developers and businesses are huge. Lower costs, definitely. Independence from potentially restrictive or expensive Western APIs. Full control over the model, which is crucial for data privacy and customization. You can really tailor it to your specific needs.
So it really feels like the ground is shifting under our feet.
It does. For the industry, it means technical brilliance alone isn't enough anymore. You need that economic accessibility, that deployment flexibility too. We'll probably see bits of all those scenarios play out.
So here's the thought I'm left with. It seems the question isn't if Chinese AI models will catch up or be competitive with Western ones. ERNIE 4.5 pretty much answers that they are competitive right now.
Seems that way.
The real unfolding question is how the entire global AI ecosystem adapts and evolves now that these truly powerful capabilities are becoming so much more distributed and accessible to everyone.
That's the big unknown we'll be watching.
So until next time, keep exploring what's possible at the frontiers of AI. Maybe even check out ERNIE 4.5 yourself. It's on GitHub, Hugging Face, Baidu AI Studio. See what you can build. And remember, sometimes the most important developments aren't the ones making the most noise.